In Chapter 7, we start to talk about what we call oblique triangles. Oblique triangles are triangles that are not right triangles. In other words, they do not have a 90-degree angle in them. If we do not have a 90-degree angle, then the traditional Pythagorean theorem will not apply, because the Pythagorean theorem only applies to right triangles, and our usual trig function definitions also do not apply, since they were defined within a 90-degree angle triangle, or within a right triangle. So we're going to start to talk about these oblique triangles and solving oblique triangles. In order to do that, we have to first discuss a little bit of information from geometry. Our three congruence axioms. So the congruence axioms basically are telling us that if we know three parts of a triangle in this order, then we can uniquely determine the other three parts of the triangle that are not given. So if we are given side, angle, side, so in other words, here's a side, the angle in between, and then another side. If these are the three parts that we are given in that order, then what we know for sure is that if I look for the other two angles and the other side, that there will only be one answer for each of those three remaining parts. Likewise, if we are given angle, side, angle in that order, in other words, let's say that we know, angle E, and then we know this side, and then we know angle D. So if we're given angle, side, angle, then the three remaining parts will be able to be determined. We'll be able to find the other two sides and the angle, and there will be only one answer for those each three remaining parts. Also, if we are given side, 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 then there's only one answer for the three angles. So these are our three congruence axioms. Also, we want to note that angle, angle, angle could describe infinitely many triangles. In other words, just because we know three angles in the triangle does not mean that we can determine exactly what the three sides would be. So the three sides could be anything, not necessarily three unique answers for the three sides. Also, side, side angle, or angle, side, side, which really describes the same thing, this does not guarantee a unique triangle. In other words, if we are given those three parts in that order, the other three parts, there could be several answers for those, or there could be no answer for those. That is not a congruence axiom. So in Chapter 7, we will be solving oblique triangles. And that means we'll be given three pieces of information about the triangle, and we'll be asked to determine the three unknown parts of the triangle. There are four cases that we will be looking at here in Chapter 7. Case 1, we will be given something like side angle angle, or angle side angle, and we will use what we call the law of sines in order to solve that in section 7.1. If we are given side side angle, or angle side side in case 2, this will lead to what we call the ambiguous case. That is not a congruence axiom, and ambiguous just means that the other side could be several things. It's not necessarily just one thing. We will use the law of sines in section 7.2 to solve the ambiguous case, or the case of side-side angle. Case 3, we will be given side angle side, and case 4, side side side. In order to solve those oblique triangles, we will have to use the law of cosines, which we will see in section 7.3. Here in section 7.1, we will look at the law of sines and use the law of sines to solve oblique triangles. The law of sines says that in any triangle ABC, remember that for a triangle we use capital letters to represent the angles, and the sides ABC, lowercase letters there for the sides, the lengths of the sides are proportional to the sines of the measures of the angles that are opposite of them. So in the law of sines, we have two potential ways that we could be using this. We have side A divided by sine of angle A, and you notice that side A is opposite of angle A, equals side B divided by sine of the angle opposite, which is capital B, equals side C divided by sine of angle C. So we can put the sides on top, or the sides could go on the bottom. Either way, this is what we would call the law of sines. We're going to use the law of sines first, if we can, to solve these oblique triangles. So here, in our first example, we want to solve triangle ABC if we know that angle A is 28.8 degrees, angle C is 102.6 degrees, and side C is 25.3 inches. So what I first recommend doing is drawing a triangle to represent ABC, so we can actually see what we're looking at here. So we're going to label ABC, and then I'm going to call this side A since it's opposite of angle A, call this side B, and call this side C. And then we're going to label what we have, what we're given. So we're given 28.8 for angle A, for angle C 102.6 degrees, and for side C we're given 25.3 inches. Now for this particular case, we're actually given two angles. And if we are given two angles and we are asked to find the third, this is a very simple calculation, because we know that if we add up all of the angles, A, B, and C, this would have to be equal to 180 degrees. So the sum of any three angles in a triangle adds up to be 180 degrees. So what we're going to do is we're going to subtract the two given angles. So we're going to subtract angle A from 180 degrees and angle C. And we can find angle B very quickly and very easily just by subtracting from 180. And so we find that angle B would be 48.6 degrees. So anytime that we are given two angles within a triangle, we can very easily determine the third. Now all we have left to find are sides A and sides B. We're going to use the law of sines in order to do this. First of all, let's look at what congruence axiom now that we are working with. We notice that we actually know an angle, and we know a side, and we know another angle. So we know angle, side, angle. And that's one of our three congruence axioms. So what that means is that since we know angle, side, angle, that we will be able to find exactly one correct answer for side A, side B, and we can use the law of sines to solve for those two sides. When using the law of sines, what we basically are going to do is we're going to take two of these fractions, set them equal to each other, and then solve the equation. So we need one unknown and three knowns within those two fractions. So what do we know? Well, in our triangle here, we know angle C and we know side C. So we're going to take the fraction that contains the C's, and we are going to fill in the information for side C and for angle C. So we're going to use, let's see, since we're solving for sides, we're going to use the law of sines that has the sides on top. So I'm going to say, well, that would be side C, which would be 25.3, divided by the sine of angle C, which is 102.6 degrees. So within the C fraction, we know both of those. Now we're going to set this equal to, and we're going to solve a fraction that either contains A's or B's, and it doesn't matter if we solve for side A first or side B here. So let's go ahead and let's solve, let's say, for side A first. So I don't know side A, so I'm going to put that on top there, but I do know angle A is 28.8 degrees. So what we have now is an equation that contains only one unknown, which would be side A. And we are going to solve for side A. We're going to get that by itself by multiplying both sides by sine of 28.8 degrees. So we're going to multiply by sine of 28.8 degrees. And we're going to do that on both sides. So we're going to multiply by sine of 28.8 degrees. And the reason we're doing that is because we want to get A by itself, And since I'm dividing by sine 28.8, if I multiply by it, it cancels each other out. Now we'll need to use our calculators here. And what we're solving for now is sine of 28.8 degrees times 25.3 inches. Divide that by sine of 102.6 degrees, and that will be equal to side A. So we put all of that in our calculator. You want to be careful how you enter it in. But when you do enter that into your calculator, you should get 12.48914,706. And we're going to round to the nearest tenth. So we're going to say that side A is equal to approximately 12.5 inches. So we're going to go ahead and label that. Side A, 12.5 inches. Okay, so we're very close to having our oblique triangle solved. The only thing that we need to find out now is what is side B. Keep in mind that we cannot use the Pythagorean theorem because we are not working with a right triangle, and the Pythagorean theorem only works for right triangles. Now we're going to use the law of sines again to solve for side B. And once again, we're setting two fractions equal to each other. If we go back up to the law of sines, we'll scroll back up. If we set two of these fractions equal to each other in an equation, we need one to be completely known, everything has to be known, and the other one has to have one unknown and one known. So we want, when we set these two fractions equal to each other, we only want to have one thing that we don't know. And that's what we want to solve for. So we know, once again, I'm going to pull out everything that we know about side C and angle C. So we know everything within that fraction. We're always going to try to use all of our knowns as much as possible, things that we were given, as much as we can, to avoid any rounding error. And we do not know side B, so we'll say equal to side B divided by, and then we're going to divide that by sine of angle B. And angle B we found to be 48.6 degrees. And we're going to solve for side B, so we're going to multiply both sides by sine of 48.6 degrees. So we're going to multiply by sine 48.6 degrees on both sides. And remember that we're doing that so that we get B by itself. These two values cancel out. And we're left with 25.3 times sine of 48.6 degrees divided by sine of 102.6 degrees. And this will be our value for side B. Put that into your calculator. Do make sure that your calculator is in degree mode, and you should get the value about 19.35010,787. And once again, we're going to round to the nearest tenth. So I get 19.4, approximately 19.4 inches. I'm going to go back up to the top just to verify that we have found everything within this triangle. So we just found side B here to be 19.4 inches. So now we know side A and side B and angle B when we were given angle A, side C, and angle C. We are asked to solve triangle ABC if angle B is 38 degrees 40 minutes, side A is given to us as 19.7 centimeters, and angle C is 91 degrees and 40 minutes. So once again, I recommend drawing a quick little sketch of triangle ABC. It does not have to be to scale, it's just to give us an idea of what we're working with here. But we are told that angle B is 38 degrees and 40 minutes. Now notice this time we're not working with decimal degrees, we're actually given degrees in minutes. So we want to be careful and think back to how do we work with degrees in minutes. Angle C is given to us as 91 degrees 40 minutes. And we know side A, 19.7 centimeters. So we have three unknowns: angle A, side C, and side B. And these are the three parts that we want to find out. What is the congruence axiom that we're given? Well, before we do that, let's solve for angle A. We said earlier that if we know two angles within a triangle, then we automatically know what the third would have to be. And we know that angle A then would have to be 180 degrees, subtract the two angles that we're actually given. So we're going to subtract angle B and angle C. Since we're working with degrees and minutes, I suggest that we add these two angles together and then subtract from 180. So we're going to sort of do it like this here. So we're going to add these together and then subtract from 180. So let's come to the side, 38 degrees 40 minutes plus 91 degrees and 40 minutes. So we're going to sum these two together. We get 80 minutes and we get 129 degrees. And we talked about before that 80 minutes is usually not how we would write that. We would actually write this as, let's go ahead and borrow a degree, or borrow 60 minutes and call that a degree. So we know that 60 minutes is the same thing as 1 degree. So we're actually going to call this 130 degrees and 20 minutes. So 130 degrees and 20 minutes is the sum of the other two angles that we were given. And we know that whatever's left over from 180 would have to be angle A. Now, when we're talking about degrees and minutes, it's important that we only subtract degrees from degrees and minutes from minutes. So I'm going to rewrite this as 179 degrees and 60 minutes. So instead of writing 180 degrees, I'm going to call this 180 degrees, 179 degrees and 60 minutes. So we're going to borrow a degree and call it 60 minutes. Minus 130 degrees, and this should be minutes. Little tick mark there, 20 minutes. 20 minutes. There we go. So I'm going to write this vertically to help us kind of visualize what's going on. We have 179 degrees, 60 minutes. Take away 130 degrees and 20 minutes. And I keep writing that as degrees, and it should be minutes. Sorry about that. So minutes, minutes. All right. So what we have is 60 minus 20. That would leave us with 40 minutes. And 179 degrees minus 130 degrees would be 49 degrees. So angle A is 49 degrees and 40 minutes. So now we know angle A. So anytime that we're given within a triangle, anytime that we are given two of the angles, we can easily determine the third by subtracting from 180. Now let's look at the congruence axiom. Now that we know all three angles, then we can actually look and see that we know angle, side, and an angle. So we know an angle and a side and an angle, and so that's one of our congruence axioms, angle, side, angle. So that what that means is that now we can uniquely determine exactly what the one answer would have to be for side C, side B, and we just determined what the measure of angle A would have to be. So let's solve for side C and for side B using our law of sines. It doesn't matter which one that we actually solve for first, side C or side B, but let's look within the triangle and see what we actually know. And we need to know, remember, one of the entire fractions, we have to know everything in that one entire fraction. So what we now know actually is we know angle A and we know side A. So we're going to use this information for the fraction with all of the knowns. So since we're solving for sides, I'm going to start with our sides. So I'm going to put side A on top, divided by sine of angle A, which would be sine of 49 degrees, 40 minutes, equals. Now this one contained one unknown and one known. And we said it doesn't matter if we solve for B or C first. Since it doesn't matter, let's go ahead and solve for side C first, since that's something we don't know. And we're going to divide that by the sine of that angle C, which would be sine of 91 degrees and 40 minutes. So we're going to use the law of sines to set two fractions equal to each other, where we know everything in one of the fractions and we know only one part in the other fraction and we only have one unknown. So within the entire equation we only have one unknown, which is what we want when we're using the law of sines. Now we want to solve for C, so we're going to multiply both sides by sine of 91 degrees and 40 minutes. We want to do that because we want these two to cancel out, and we only want to have C on one side by itself. And now we need to put this into our calculator. So sine of 91 degrees, 40 minutes times 19.7 divided by sine of 49 degrees, 40 minutes. Now we want to be careful how we put this into our calculator, and I'm going to put in 19.7 first times, and we want to convert to decimal degrees before we actually type this in. So I'm going to type in sine, and the parentheses are going to be in the calculator. And we're going to do 91 plus, we're going to convert this to decimal degrees. We're going to let the calculator do the work for us. 91 plus 40 out of 60 minutes. And that's important. We're going to convert to decimal degrees within our calculator. We're going to divide that by sine of 49. And once again, we're going to convert to decimal degrees. So we're going to say 49 plus 40 minutes out of 60 minutes. We're going to get a value for C, and I get 25.83218,524. And we're going to round to the nearest tenth again. So I want to say this is 25.8 centimeters for side C. So I'm going to come back up to our triangle and I'm going to label side C to be 25.8 centimeters, since we now know that part. So 25.8 centimeters. So the only thing that we don't know now is we do not know side B. We're going to use law of sines once again to solve for side B. And earlier we set up a fraction where we had two knowns within the same fraction, and that was describing angle A and side A. And we're going to use exactly that same fraction again because we know both of those parts. So 19.7 divided by sine of 49 degrees, 40 minutes, equals, and this time we're going to solve for side B, so we're going to put B on top, divided by sine of angle B. So this time we said angle B was 38 degrees, 40 minutes. We're going to multiply both sides. To solve this equation for B, we're going to have to multiply both sides by sine of 38 degrees, 40 minutes. And that way these two will cancel out and we're left with B. And we're going to put all of this into our calculator once again, and we're going to make sure that we convert to decimal degrees as we do that. So we're going to multiply 19.7 times sine 38 plus 40 divided by 60, close parentheses. So we're going to let our calculator convert to decimal degrees while it calculates the sine value. And we're going to divide once again by sine of 49 plus 40 divided by 60 minutes. And we're going to put all that into our calculator, and we get 16.14648.341. And I'm going to round to the nearest tenth again. So we'll say that B is approximately 16.1 centimeters. So when we're setting up these equations, remember that within the fractions we want to know everything for one complete fraction, and in the other fraction we want to know one part, and then we only want to have one unknown within the entire equation. And once we have set up our equation, we can solve for the unknown. And here we want to be careful how we put this into our calculator. We want to convert to decimal degrees within the sine function. Let our calculator take care of all of that for us, and make sure that you can get this value for B, 16.1 centimeters. And we're going to go back up to our triangle, and we're going to verify that we know now all parts of our triangle, and we see that we do. Now we know all three sides and all three angles.